So I think I'm going to get started. I got the thumbs up. I'm Mike May. I'm the technical director at Data Machines, and I'm going to give you guys a talk really quick on how we're doing research in cloud-style deployments, which are production-style deployments. Really quickly, I've been doing this for, as baby faces I might look, for a while. Done 30+ cloud deployments. 4 of them are currently active in actual production clouds, not research-based clouds for the US government. 6 of them are simultaneously research clouds at DARPA, which if you don't know who DARPA is, it's the United States military research branch. They're funded out of the DoD fund, and a lot of the push lately has actually been to do a lot more open source. So we are pushing all of our clouds to be almost 100% open source. And I will show you in a second, there's one exception because for some reason the government really likes it. But my background, I used to be a cyber warfare researcher. I still enjoy doing that. And I used to be in the United States intel agencies doing a bunch of the cloud deployments for them and helping them secure and actually understand what a VM was, which a few years ago was not something they truly understood. I'm now sort of transitioning, I'm sort of doing this HPC systems engineering, and I've been doing OpenStack since 2013, and I call myself a stacker where I actually had a successful OpenStack deployment. I had a few failed ones in 2012 that were personal. So our company, there are 10 active R&D programs. Of those I had earlier, there are 6 clouds total that those 10 programs are running on. We design and deploy infrastructure as a service from completely upstream. We don't deploy anything where something or somebody who wanted to reproduce what we were doing, who's on our programs, they couldn't get without paying somebody else or us. So we do OpenStack, Mesos, Kubernetes, and we burst to the cloud if necessary. That last bullet is very hand-jammed. We actually do that very custom per program because those are so special, at least in terms of how DARPA does it, and there are different requirements per program. So right now, we don't have a generic way of doing it because we can't, but that is something we're interested in doing. And then, in general, the research is very diverse, but it is data science and data analytics heavy, just so you guys know what's on the clouds. Yay, icons. Here's what we deploy and what we use. There's the Confluence icon I mentioned earlier. There's one thing we pay for, and it's Confluence. For some reason, everybody wants us to install Confluence, so we let them pay for it. It's not us paying for it. They pay for it. And we put it on there, and there you go. I mean, otherwise, this is kind of your standard what people are using nowadays, but we've been running this for 3 years total. Some of these have changed in 3 years, but as things have matured, these icons get replaced out, and you can imagine what they were before. So, Banana for Scale, one of the DARPA programs that runs both OpenStack and Mesos. I'm not going to read all those out, but there you go. It's a pretty decent-sized cloud. It runs across 2 racks, so it's fairly simple in terms of what it looks like. And we have both bare metal, Mesos, and OpenStack installed on bare metal. We have Mesos bursting into OpenStack, which is kind of cool because this program in particular is really interesting in the fact that the program, when I initially deployed this cloud, is going to be very OpenStack focused, and it still is. And we're about to, this month, have to shift to a more Mesos focused cloud. We have GPUs in this environment where GPUs in OpenStack are designed for the researchers to do their development, and that's great because having them have their whole VM and they can totally mess it up in every way possible with all the new deep learning libraries that don't install very nicely the first 7 times someone tries it. Anyway, we've got more on that later, but the GPU batch jobs then are in Mesos, so the GPUs that are in the Mesos cluster are designed for batch sort of style jobs, and all of this from top to bottom is open source. So how we use it is we try and get as close to the seamless development to production experience. So our researchers are doing this, they're developing, they're doing a lot of work in the VM, and we need them to immediately take the work they've done in the VM and get it into a production state. And I love researchers. I do research myself. They're not very good about production. They don't really understand production because they don't care. They need to get their experiment done, and they don't really, like, I'm going to do what I need to do, my experiment done. Great. So we offer a few things that sort of help them wrap that up and transition forward. So a lot of things we're having them do now is they do a lot of dev work, and then we have a pipeline that converts most of their dev work into just single Docker container, which is pretty nice. That's, again, fairly program specific, but we're starting to make that more generic and is something we're actually looking to potentially release. So we have simultaneous provision and batch job support. The CI/CD process is actually designed here for the researchers to promote work as a team and as a program. So some teams need to have their work promoted at the team level, and then some of that work eventually needs to get promoted at the program level, the actual DARPA program level. And our processes are very interesting in that way, that we have this sort of double promotion status. But it makes a lot of sense when you think about the research context and why that would be that way, especially a sort of a government-funded one. And then one of the other big things I like to add is we layer 2 isolate by default, which is actually most of the default ways that OpenStack will deploy, is you leave your layer 2 isolation on. So for example, VLANs for every neutron network. That is hugely important to us, and that accomplishes. It gives us the basic level security on the bare metal and the network to keep the researchers separate. We're not worried too much about if a researcher tries to be evil. We don't actually care that much because they're all on the same team on this point. But this way they can, anything they want to do or they think they want to do, they can do without harming anybody else. So that's really the key there. That's and why I like to include it. We Ansible-ize all the things, all of them, and we make sure that item potency is about number 2 to actually doing the Ansibles. So for us, we have this basic assumption. What I tell my team is if you've done a task more than once, it should already be automated, or you've already thought about automating it, or was already in a bash script. Because, 1, it's easier said than done. It's actually a big pain in the butt to do it. But 2, if you don't do it right off the bat, when it's at least semi-small or semi-fresh in your mind, or both, it's never going to get done. We've got way too much to do. Research moves way too fast. One of the reasons that this talk is titled this way, and part of the description is, we change this cloud all the time. We change how the nodes are configured. We enable NUMA. We turn off NUMA depending on who's using it. Half the nodes are in aggregate groups for one thing, half are in another, and then the next day they're different. We take nodes in and out of OpenStacks regularly, and that sucks. But we've gotten pretty good at it. And by that I mean I have, and by that I'm sad. So anyway, this is one of the repos that we have that we started, and this is big for us in the fact that internal to the DARPA projects, there's no reason that we as the cloud operators should hide what we're doing. So I told you that we do everything open source so that basically they can repeat it. We do it for the changes we make to the cloud. So even in here, you can see that there's quite a few random common projects as well, but we also have, and it just says tasks right here, but that's the program-specific tasks that are going on for that specific cloud, and in there, all of the changes that we need to make to that cloud to make that program run and interconnect with its LDAP and all that good stuff. That is 100% reviewable by every team on the program. And in fact, they contribute to it. Especially if they really need a change or really need something on that system, we can do it. For example, we disable Swift by default because we find that the researchers we're working with don't understand how Swift actually works, so we don't want them using it in a bad way. We have some that really like it, so they can contribute back if they all agreed to it, how to use Swift, and then they use it right. And then we also have some tools that we're still working on open sourcing, but we're fairly close. We have a problem with researchers want to get their work out there and have it publicly viewable, and for example, like I need to access it from China and I can't VPN over to the States. So causes a small problem. We don't want users setting up their own proxies, so we wrote a proxy mapping tool that they could use on their own, creates a full audit log for us, and we automatically put authentication on top of it. So it's basically Nginx with LDAP tied into it, but it's just a quick mapping tool. Super simple, super powerful. Saves us a lot of work, and quite frankly, the users don't come bug us as much, which is great. And they can turn it on, turn it off as they see fit. And I think I'm a little bit early, so I have a lessons learned slide, and I'll throw it up there because I already hit some of those. But one of the really big ones that I think is really, I say researchers here, I think it's very relevant to everybody. Researchers are biased, and so are we. I know I'm extremely biased in the way I deploy OpenStack and Kubernetes and how I think about Docker and what I think about other people thinking about Docker and stuff like that. That's really important to get right in a collaborative environment that's so research focused. I have to find a way to throw my biases out, and the way I did that was that's why we made our code public to the programs. I could no longer be as biased as I wanted to be because somebody eventually would call me out. Why did you do it this way? Why is this not HTTPS? You know, blah, blah, blah. That was a bad example, but it helped flush those things out. And in general, when we do push these to open source in general, it's going to be that much more robust of a piece of software if we do, or a collection of tools, I actually would say. We have to always also have evacuation as an option. If a node is misbehaving, we do our best to burn them in. We do our best to maintain them. Stuff happens. And we always have to have room to evacuate a box or two. And we can't, so I'm going to be doing a longer version of this talk tomorrow. And I can go in deeper then, but the basic idea is we do enable over-provisioning. We are very picky about how we enable over-provisioning, but we have our reasons, and this is one of those reasons. And we've had to hit this a few times because bad things do happen. And if you're not ready to evacuate an entire box, and this happens a lot in research communities, it doesn't happen as much in this DARPA side because we have a little bit more money, and by that I mean we have a lot more money to work with in research universities. But actually, I was just in a talk where the guy speaking about Agave platform was mentioning that, or no, it wasn't the Agave platform, it was the guy right before him. Anyway, that the moment they add a new box and allow workloads on it, he's over-provisioned by 20x on that box because they had to make so many promises just to get that one box that once the box is on, they're going to use it because a bunch of people are now on the system, et cetera, et cetera. And you still need to be able to evacuate, and that's hard, and not everybody can do that, but for us, we have to because, and here's the wrap-up of the presentation, is very quickly, we've had multiple DARPA programs that were very research-based become production-ready. And that was not my choice or anyone else's choice. That was a government official saying, we're going to use that today. Oops. We can no longer take the system down. We can no longer, it's running in the exact same place where researchers are working on it. No one was ready for it. It is now production. Congratulations. Cross your T, dot your I, all the good things. You have to now start running under those assumptions. So everything I was saying, all of that actually now has to be true, and it was at the drop of a hat. So it's a little different perspective. It's a little different use case. It's one of the reasons why we still come here, why I contribute to OpenStack, because it's slightly different in terms of the way you need to think. It's not special. There are others like it, but I'm a fairly vocal person, so I like to make sure that I speak out. I think I have 2 minutes for questions. Maybe less. Maybe I went over. 1 minute for questions. Go ahead.
Did you bother making your pipeline for Dockerizing a dev project into a production project?
We just got some more money to actually put some real work into that, and that is very focused on this one project right now, but we've had to design it in a way that is fairly generic, and as long as we get approvals, I think we can do that. So that'll be kind of cool. That'll be very interesting. There's a little bit of metadata that we have to collect, but past the metadata, the system kind of kicks itself off, and it's pretty cool. So hopefully, yeah. But we have GitHub/data machines, so you can watch this anytime. All right. Thanks, guys.